So I'm going to give a scenario and sort of walk through how a team would use Panther from start to finish, and we'll walk through a sample scenario. So let's imagine for a moment that you have a fleet of virtual machines and some SSH credentials are phished. Let's also say that there's no two-factor authentication for SSHing in, and an attacker gets in and starts enumerating around, seeing what access they have. What can we do as a security team using Panther to detect, investigate, and remediate this? So some terms I want to lay out before I get into the scenario. So when I say a resource, I'm referring to a cloud component like a virtual machine or a user or an S3 bucket, something like that. Uh, Policies are functions representing the desired state of those resources. And then on the log analysis side, a rule is a detection function for looking at suspicious activity on events, which are this normalized log data that's come in from either your host, network, cloud sensors, anything. And then finally, alerts are those things that we get at 3 in the morning when someone hacks into all our stuff. So moving on. The incident response lifecycle, if you've been working in incident response for a while, you've probably seen this a lot. NIST has the famous 4 phases, but really where we start is, we want to build some detections. We want to detect our activity, and then we want to start to gather our indicators, our evidence, do some queries on all of our log data, and then we want to contain the incident, do a postmortem, and then we want to update our detections again. And then this cycle sort of continues as time goes on, as the team gets more mature, adds more data, etc. So in Panther, the way this looks like is, we first craft our detections. So this screenshot just shows our list rules page. And in this page, we can sort of filter out all the existing detection rules that we have today, either by its type, its severity, some customized tags, etc. And then, either in the UI or on the command line, you can, using Python, craft these detections. So the first one that we're going to look at for this scenario is somebody logging into my instances from a non-office network. And in this example, we're using just a sample /24, but this can be really effective if you have specific egress points for logging into your systems, which most companies do, either with a VPN or with specific office networks. So this rule function takes in an event, which is our parsed log from OS query in this case. And then we're checking the host column, making sure it's within the network. As you can see, we're using the Python IP address library, which is also sort of just leads back to the fact that Python is really powerful and you can get really creative. The next thing we want to look for and we want to monitor for more generally is a volume of access denieds in our Amazon account. So using CloudTrail, you can monitor this, and this can generally indicate either misconfigured automation that's happening, or it could be someone who got access to access secret keys, and now they're trying to enumerate around and see what they can do. So the next step is, now that we have our detections, let's actually detect and let's triage. So this is the screenshot from our hacker. They log into our network from a non-approved IP address, as we can see here. And then what they start doing is saying, okay, do we have the AWS CLI installed? Okay, we have it installed. What can we do? Can we get users? Can we list? Can we create things? And we see a bunch of access denied here. Some of these might succeed, some of them might fail. Let's take a look. So the detections that I set up, I have it configured to send to Slack. So in our Slack channel, obviously you wouldn't want to use Slack for a high priority one. In a real scenario, you would use PagerDuty or something that actually would call your on-call. But for the purpose of this demo, let's just say it writes to Slack. So in this view, we see, okay, we get an alert from someone logging in from an outside network, and we see a second alert right under that, which is monitoring unauthorized API calls. So when we click through to our UI, we can get more information on those events, and we can also configure with our rules certain logic to merge the events based off of either time, the user creating, the user causing the activity, the host. You can really control that however you want. But from these triggered events, we can start to gather some of these indicators, such as, what's the IP address that this attacker logged in from, what's the compromised user, and what is the instance that they connected to. So taking this information, we can sort of pivot around to SQL, and then we can write a query that essentially gives us what the instance ID is for the IP address. So this query is essentially looking at our VPC flow logs. And when you're writing queries, and this is in Athena, you would look at the Panther logs database, which is all the log data that you send into Panther. And then the flow log table is all the AWS VPC flow logs. And we're filtering based off the time frame of this alert. And then what we get is an instance ID that we can take and we can get even more information on. So as I mentioned in the beginning, Panther does baseline scans of your entire AWS account or multiple accounts. You can really onboard as many as you'd want. And what you get is a way to view all the attributes of these resources. And then that allows us to understand certain important state information during an incident. So if we look down, and I apologize if this is hard to see, but now that we know the instance ID, we can pivot around into the resource attributes. And now we have the IP address of the host, we have the fully qualified domain name of the host, and just other things that we can use to further pivot and get even more information. So now that we start to, now that we have the instance IP address, let's see what else happened in this time frame for this instance. So we take the public IP, we see, okay, there's some logs in CloudTrail. If this IP showed across any of the log types, we would see them listed here, but this is querying a different database. So we have an idea called a view. I guess it's a more sort of generic database concept, but we have a table or a database called Panther views. And this allows you to really take these indicators and search across all of your log data and then look at that log data further. So this is telling us, across all of your log data, I found AWS CloudTrail as a related log type for this IP. So we can pivot again, and now we can see, okay, let's look at the CloudTrail for that IP address for this date and time. And now we start to see the access denied calls, more context, and we can just really crawl through this data and get a better sense of everything that happened within this time frame. So, we can continue our investigation. We can sort of determine what the blast is of this breach. We can then remediate with Panther itself if you wanted to. Oh, sorry about that. So Panther has automatic remediation. I mentioned this also in the beginning. So the way this could work is, we have policies that are set up looking at your network ACLs, looking at your security groups, et cetera. And we have remediations that, when you click this button, what will happen is a role will get assumed, it'll make an API call, and it'll fix whatever this resource is. And this is really helpful for containment. Less so as a scalable way of doing configuration management. It's more so just for, in the event of an incident, you need to remediate something really quickly. This is one way you can do that. So you can click remediate, it'll go do that, and then effectively that would cut off the access. And then, we can shut the instance down, we can do forensics and just more in-depth investigations.